For today's day 3, I can solve system by using elimination. We're going to try out a new method for solving our systems of 2 equations. Before we get to that, we'll go over the warm-up that you did. So we started with a system of 6x minus 3y equals 21 and y equals x minus 2. The directions were to use the letters A, B, C, and D to kind of reorder the steps that should have been taken to solve by substitution. So if you remember from substitution, you're supposed to find where the isolated variable is at, and then whatever it equals replaces the same variable in the other equation. So that should have been step 1, which means we would have replaced the y with x minus 2 using parentheses, and it looks like that should have been step D. So that would be the first thing we need to do. And then after you've got your substitution created, you need to distribute if you see any parentheses. So if we were to distribute, we would get negative 3x plus 6 left over, and so that would be step B. On the left side of the equation, we can see that 6x and negative 3x are like terms, so those could be combined to give you 3x. And then the plus 6 and the 21 would still be left. So now we're on step A. To get the next step, you would have had to subtract 6 from 21, and that's where the 15 comes from in step C. So if we finish that solution, dividing by 3, we would get the first solution is x equals 5. But now with x equals 5, we need to go back to one of the equations. I'm going to use the second one, y equals x minus 2, and I'm going to replace the x with 5. So if y equals 5 minus 2, then y would equal 3. But don't forget that when you solve a system, you write it as an ordered pair with the x and then the y. So 5, 3 is the solution, and this would be considered an independent system if we needed to classify. For graphing, I noticed that the first equation is written in standard form. So I try to set the x equal to the constant, but I don't want negative x equals 3, I just want x. So I have to divide by negative 1 to find out that x is on negative 3 when I graph it. Then I need to do the same thing, but for y. I have 1y from the first equation equal to 3, so the y-intercept is at positive 3. If I want to graph more points, I can count that it goes up 3 and right 3, which is really up 1 and over 1 for more points on this line. So I'm going to get as many as I possibly can, because we said we want to always extend the first line so that when we're ready to look for an intersection, everything is accurate. Don't forget to connect your points to actually create the line. And then I'm going to go ahead and start graphing the second equation. This one's in slope-intercept form because y is all by itself, so negative 3 would have to be the y-intercept. So that's where I start. If my slope is negative 2, that means down 2 and over 1. You have to remember there's a 1 underneath this 2. But if I go down 2 and over 1, I'm not headed towards the other line, so I'm going to start changing direction. I'll go up 2 and left 1. I still have not intersected, so I'll try again. Up 2 and left 1, I do see the intersection now. So I'll go ahead and connect my points of the second line. There's no need to keep graphing if I already see the intersection. Okay, and so the point where they're intersecting, I'm going to go ahead and highlight that in green, is here at the negative 2, 1. Sorry, I'm having some trouble. Negative 2, 1 on the graph. So that would mean the solution is negative 2, 1. And since we were able to find one answer, it's an independent system. So outside of substitution and graphing, as I was saying earlier, we have elimination. We're actually going to be covering elimination in 2 different parts. Today, we're not going to have any manipulation on the equations, which involves some multiplying and then adding and subtracting with that. We're just going to work with adding and subtracting today. So that's why you see these plus minuses up top. I'll be using those during the examples. No matter what, we write our solutions as ordered pairs when we're solving systems, whether we graph, substitute, or eliminate. So step 1 here for elimination says that we want to line up the like terms. Most of the time this is done for you, but let's talk about what it means. All of the x's are lined up on top of each other. All of the y's are in the same location, and the constants as well. So we're happy that the equation is set up that way in order to eliminate. If you want to eliminate a variable, you need to look for the variable x or y that either has opposite or same coefficients. So in example 1a, the x's both have a coefficient with 4. One of them just happens to be negative. So this is the variable that we're going to eliminate. We're going to focus on that first. We can't eliminate the y's as they are because they have different coefficients. The first y is 1 and the second y is negative 4. So it needs to have the same number but possibly opposite signs, and that's okay. The rule says that if you have opposite signs, like our example here, we're going to do some addition. So what I like to do is put a big old plus sign when I know I'm going to need to add to eliminate, because I'm not only going to add the x's to eliminate them, but I'm also going to add the y's in order to come up with a new term, and then I'm also going to add the constants from the equations. So I will be eliminating or canceling out 4x plus negative 4x because 4 plus negative 4 is just 0. So we're left with 1y minus 4y, and that's going to give me negative 3y when I add it. Since I added the x's, I have to add the y's. So one more time, this is a 1y, and I am adding it to a negative 4y, and that leaves me with negative 3y. Now I want to take the negative 16 and add it to 28. So that will go on the other side of the equal sign. And negative 16 plus 28 is 12. We can divide by negative 3 to get that y equals negative 4. But just like graphing and substitution, one answer is not enough. We need to take our answer for negative 4 and plug it back into one of the equations. I'm going to go to the first equation where it starts with 4x plus y, which is just negative 4, and equals negative 16. So I'm replacing the y value with the answer I just found for y. So if I start simplifying, I have 4x minus 4, because plus a negative is still negative, equals negative 16. I need to add 4 to both sides in order to start getting x by itself. So negative 16 plus 4 is negative 12. And if I divide by 4, I'll get that x equals negative 3. So my final solution needs to be written as an ordered pair with x going first and then the y. So just like substitution, once you have found one of the answers, you need to plug it back into an equation in order to come up with the second solution. This would be an independent system, don't forget, because it has one equation. Now let's look at part B. I want to first find the variable that seems to have the same or opposite coefficient. If I look at x, it's a 6 versus an 8, so that does not help me to eliminate. However, the y's both have negative 6. Even if one of them was positive, that's okay. It's still going to be the eliminating variable. So in order to eliminate the y's, to be able to cross them out, if they're being subtracted, we need to use, if they're the same coefficient, we need to use subtraction for this entire system for those y's to eliminate. So we're going to subtract everything, like the x's, for example, and then we're going to need to also subtract the constants. So if you know you have to subtract to eliminate your variable, you have to keep subtracting everything else. So 6x minus 8x gives me negative 2x. The y's are canceling. And then 6 minus 20 is negative 14. If I divide by negative 2, I get that x equals 7. And now that I know the x, I should be able to replace it in one of the equations. You can pick which one. I went with the first. So my 6 times x is now 6 times 7 minus the 6y equal to 6. That gives me 42 minus 6y equals 6. If I subtract 42, I get negative 36 on the right side, and if I divide by negative 6, y is positive 6. So now I have my two solutions. I need to put my x and then my y into the ordered pair. Here we have some more examples, and then to finish up the video, you're going to notice that there's the check-in section just with answers. but not the actual work. So again, if those are problems that you try out and you can't figure it out, you need to ask questions on your own, whether it's in class or outside of school. So it does say solve one system, but it might not hurt to go ahead and try a couple of these out. So back to example 2. I want to solve using elimination. So I'm going to look for the same or opposite coefficients. X has 3 and negative 3, so it could be used to eliminate. Y could also be used because they have opposite coefficients. So just for the heck of it, I'm going to go ahead and eliminate the y's as my work. So if I want to eliminate the opposites, a negative and a positive, then I have to add. So that's from before. So sorry about switching the screen. If I want to add this, I have to add everything in the problem. So as I'm going through, 3x plus negative 3x is actually going to cancel too. Negative 3 plus 3 cancels for the y's, but then negative 10 plus 0 does not cancel out. So this whole left side cancels, meaning the left side is worth 0, but if we add up on the right side, we get negative 10 plus 0 is negative 10. But 0 does not equal negative 10, so this has no solution because it's not true. And if it's no solution, it's an inconsistent system. So you will run into these special cases when you're working even with elimination or substitution. So if we look, and sorry, I'm going to switch screens here again for a second so I can have my minus sign if I need it. If we look at this next one, the coefficients for both variables are the same. I have negative 10 for both x's and 4 for both y's. So this time I'm going to go ahead and work on the x's for my elimination. If they're both subtracted or they're both the same coefficient of x, negative 10, then we need to subtract through the whole system in order to eliminate. So everything in this problem will go through subtraction. Negative 10 minus a negative 10 cancels out to 0. 4 minus 4 for the y's also cancels out to 0. So right now on the left side of this equation or this system, I'm left with 0. Everything canceled. And then if I go and try to do 26 minus 26 for eliminating, I have 0 again. So if 0 equals 0, that's always true, which means there are infinitely many solutions for this system. You can't even find them all. And that makes this a dependent system. So when you run into cases where two things don't actually equal each other, or they always equal each other, don't forget it's a special case of either no solution or infinitely many solutions. And then those special cases are called inconsistent and dependent systems. So one more time, we have our check-in problems. You should definitely attempt one of them, but it wouldn't hurt to try them all. Check how you do, looking at the answer and the classification, and if something doesn't work out well, just ask a question.